And now I have 108 divided by n squared times this, n. I'm going to multiply these already. So it's 2n squared plus 3n plus 1 plus 12 over n times this, n plus 1 divided by 2 and minus n. Next, can I simplify everything? Yes, except n. Okay, so I'll get rid of one n. I will not get rid of this n, but I will get rid of this 2, and I will get rid of this 6. What am I doing? Right? Yes, 18. What else? And this one needs to be multiplied by n. So the least common denominator, it's very nice and clean, just n. And I'm on page 4. Yes, on 4. So from here, limit as n approaches infinity, 6 over n. Nice denominator, just n. There is nothing else. I will distribute 18 to these three terms. 36n squared plus, I think it's 54n and plus 18. Yes, I think so. Plus, this is n. 6n squared plus 6n. Of course, you know, I always run out of room. Plus 6n squared plus 6n minus n squared. Okay, so then this is limit as n approaches infinity, 6 over n. 36 plus 6, 42n squared. These are accounted for. 54 and 6 plus 60n accounted for. Oops. Oh, minus n, 41. And plus 18. At this point you can stop, but let's say we don't see it yet. So this is 6 times 41 n squared plus 60n plus 18 over n squared. If you remember this from pre-calculus, same degree over same degree when n approaches infinity is 6 times 41 over 1. You can say, no, I don't see it. You can put 6 in front and differentiate the top using L'Hopital's rule because we have infinity over infinity. So then we have 82n plus 60 divided by 2n. Again is infinity over infinity. And the numerator will be 82, the denominator will be 2, so it's 41. 6 times 41. So 246. And now the integral from 0 to 6 from 3x squared plus 2x minus 1 dx. I better get that. I don't want to go back. Okay, 3x cubed over 3 plus 2x squared over 2 and minus x from 0 to 6. How nice. I didn't mean it. So 6 to the third plus 36 and minus 6. So is that 216? Six to the third.
Yeah, it's 216.
Good. And plus 30. It better be 246. Ah. Good. So that was the area with the limit of the Riemann sum. Yes.
So when we're like solving it, do we also have to do the like check it on the bottom like you did on your test?
I will ask you to.
Okay. It's like
You don't have to, but I will always do it myself. It's so easy to, you know, forget something or mess up a sign and I get something that is an error. It's very easy to mess up this somewhere. Very easy. All these steps, a lot of calculations, algebra. Very easy to make a mistake. So for some reason in my head I had 3 times 36, and when I divide by 6 I said, oh, it's 36. Oh, no, it's not 36. I had something else in my mind. So it's very easy to make an error. I will ask you to do this and check. Good. Next question. Or maybe you have something else in mind. Anything. Anything else?
I got a question from the book.
Yes, I'm ready.
Chapter 5.2. It was first one of the questions to me.
So I'm on page 5.
I think I had an idea what they were asking for, but I just wanted to confirm it.
Let me go back. You said 5.2.
Correct.
Here it is. Number.
60.
Am I in 5.2? Yes, I am. Okay. So that was, I'm going to stop sharing because I think this was a homework problem, wasn't it? I didn't write solutions for it?
No, it's right there on your first page.
Oh, the very top. Yeah, right. Sorry. So it's the integral from 0 to 5, but you have a function that is 3 between 0 and 3, and it's x between 3 and 5. So you have to break the interval between 0 and 5 into 2 intervals, from 0 to 3 and from 3 to 5. So the antiderivative of 3 is 3x from 0 to 3. The antiderivative of x is x squared over 2 from 3 to 5. So when I plug in 3, I get 9. There is no need to plug in 0 because I get 0. When I plug in 5, I get 25 over 2. And when I plug in 3, I get 9 over 2. When you perform this, you will get 17.
Okay, so on the where it sets up the like the bounds, even though it's 3 for x is less than 3, it's not the integral of 0 to 2. It's still 0.
Very good question. Okay, let me share my screen again so I can copy. Let me put this aside and let me copy. So we have the integral from 0 to 5 from f of x dx. And the function is f of x 3 for x less than 3 and x for x greater than or equal to 3. Very good. Good question, Mark. Thank you. So first of all, when we talk about this interval 0 to 5, the function must be continuous on 0 to 5. And it is. It's continuous to the left of 3, it's continuous to the right of 3. And what about 3? We know continuity at x equals 3. The limit from the left of 3 must equal the limit from the right of 3 must equal f of 3. This is 3, this is 3, and this is 3. So the function is continuous everywhere. Therefore, I can determine the integral from 0 to 5 from f of x dx. But if you graph this function, I'm only interested between 1, 2, 3, 4, 5. Very good question. Less than 3, the function is 3. I should go on, but I'm only interested between 0 and 5. And on the right hand side, greater than or equal to 3, when x is 3, y is 3, I fill it in, and 4, 4, and it's just this line that bisects the first quadrant. So as you see, let me extend it. So we are interested in this area. And remember, when I determine this area is the area under the function called 3, and this is the area under the function called x. And it doesn't matter, first of all, the function is continuous, but it doesn't matter in here because the integral from 3 to 3 from f of x dx is 0. Right?
From 3 to 0?
Yes, because there is no width. From 3 to 3, when I calculate the area of delta x times f of x, this is 0. 3 minus 3 is 0. So the width of this interval that is 3, from 3 to 3, the width is 0. So 0 times f of x will be 0. This is one of the properties of the definite integral. The integral from a to a from f of x dx will always be 0. But this is less important. What is important is that the function is continuous on this interval 0 to 5, and under this graph I have from 0 to 3, and under this graph I have from 3 to 5. The functions are not the same. This is one function, but between 0 and 3 is 3, and between 3 and 5 is x. Is this better?
Yeah, the continuous part helps a lot.
Yes, of course. Good. Very good question. Next. Did you get a chance to look at the previous solutions, a previous test, and also I posted a previous final with solutions? What would you like to continue with?
Can we do a total of change problem?
Yes. I have one here that I just wrote solutions for. With the total distance. You want to choose another? You want to talk about this one? We don't have to talk about this one. We can choose another.
Can we choose one from the book?
Yes. So the problem I just wrote solutions for, I think it was this one. I do not remember if we did, I don't think we did 69, did we?
I don't think so, but that one looks good.
Okay, perfect. Let's do 69. 69 and 5.4. Let me just copy it. So v of t equals 3t minus 5, and the interval is 0, 3. And we are asked to find the displacement and the total distance. Perfect.